All right, guys, so here we go. Let's do section 4.4. So again, turn to your book and follow along if you would. I'm going to be just doing the examples out of the book. Also have your calculator in front of you because we're going to be doing some graphing for this section. So polynomial graphs and turning points. We're going to be graphing different polynomial functions today. A couple of things that you have to be aware of when you're graphing these. It says that p of x is a polynomial function of degree n, and the graph has at most n minus 1 turning points. So if it's a fifth degree polynomial, it has at most 4 turning points. That's what it's getting to. So it'll help you try to determine what graph is what. So if the graph of a function p has n minus 1 turning points, then the degree of p of x has at least n. Kind of the converse of what we just talked about. The graph of a polynomial function is a smooth, continuous curve. So there's no cusps or no hard corners in it whatsoever. So it's going to help us. Some of the first questions we're going to be asked are, is this a polynomial or not? So looking at a couple, determine whether each graph could be the graph of a polynomial. If not, tell me why. If so, use the number of turning points and zeros to identify the least possible degree of the function. Okay, so for this first one, this is not a polynomial. You have a cusp here. It comes to a sharp point. Polynomials are supposed to be smooth, and that's not the case. All right. Whereas b, that is definitely smooth. That is a polynomial. Okay. We can see that it crosses the x-axis 3 times, and we know that potentially it has at least a third degree polynomial. And then there's 2 turning points, and from what we saw in the previous slide, that kind of verifies what we're talking about. So there's a minimum of third degree. So this is an x to the 3rd type polynomial. Okay. How about this one? Definitely smooth. Okay, so we know that it's a polynomial. It crosses the x-axis in only 2 places, so maybe it's a quadratic, but we change directions 3 times, so there's 3 turning points, which means it's a minimum of a 4th degree polynomial. Okay, so this would be 4 for part C. D, well, that's not a smooth curve. It's not even continuous, you guys. Okay, they're not connected here, so that is not a polynomial. So this is a 4th degree, and that one is not a polynomial. Identify the end behavior of the following functions. And so all we're talking about end behavior of a polynomial is, are we going up or down when we go left to right? So your quadratic, I would call that up, up. Okay? If it's got a negative number out in front, so I flip it over the x-axis, I would call that down, down. If it's a cubic, the positive leading coefficient, I would call that down, up. Negative leading coefficient would be up, down. So this is a 3rd degree polynomial with a leading coefficient that's positive. It's going to look like this. Okay? I'll give you a little sketch of, in general, it could look something like this. So this would be considered down, up for the end behavior. Okay? This is a 5th degree polynomial, so odd degree. Leading coefficient's negative. And so because leading coefficient's negative, that's going to switch it this way. Okay, so now we're falling. Okay, so this is going to be up, down. Okay, this is a 4th degree polynomial. Since it's an even degree, they either both go up or they both go down. Leading coefficient's negative, so it's going to be something like this, which will be a down, down. Okay, that's all I'm looking for in that situation. So as I go left to right, we go from down to up. This one goes from up to down. This one goes from down to down. These are just the general characteristics of the end behavior that we talked about. And we've already mentioned this. If it's even and the leading coefficient is positive, up, up. Leading coefficient negative, down, down. If it's an odd degree, leading coefficient positive, down, up, negative, up, down. That's all this page is telling you guys. State the end behavior of each function. Okay? Even degree. Leading coefficient is positive. So there can be a bunch of turning points in there, but in the end behavior is going to look something like this. So we would call this up, up. Okay? This one is an odd degree. Leading coefficient negative, so it looks like this. Okay? So it's falling like so. So this is an up, down. And if you're not 100% sure, you guys, you can always throw those into your calculator and see what happens. What does it look like in the end, okay? Zeros of multiplicity. So we talked about multiple zeros in the last section, but what does that look like graphically? So if you have a zero, so if x minus c is a factor, c is a zero, raised to the m power means multiplicity m, okay? If m is odd, so multiplicity 3, 5, 7, the graph will cross through the x-axis at c, and it will become a little more compressed or flatter where it crosses the x-axis. If m is just 1, it's just going to cross through it. But if m is 3 or 5, it's going to get a little flat right at that point. Okay? If m is even, the graph bounces off the x-axis. So it touches the x-axis and then changes directions immediately. That's going to help us determine what our graphs look like a little bit. Okay? So the graph of a polynomial is shown. We don't know what the polynomial is at all right now. State whether the degree is even or odd. Well, I should know that just by the end behavior. We're going from down to up ultimately. And so that has to be an odd degree. Okay? Use the graph to name the zeros of f, then state whether their multiplicity is even or odd. Okay? Well, it looks like we crossed the x-axis here at -3. And because we cross, it's odd. If it was bouncing at that point, it would be even. So -3, we're going to say odd. We cross again over here at +2. And that would be considered even because we come down and we touch at +2 and we go back. State the minimum possible degree of f. Okay, well, we know it's got to be an odd degree. And we know that that is at least a second degree because it bounces off. This one, because it didn't just cross but it got compressed, is at least a third degree. So multiplicity 3 here, multiplicity 2 here, 3 and 2 gives me a minimum of a fifth degree polynomial. State the domain and range of f. Okay? The domain, this polynomial goes left and right forever. All real numbers. The range, this polynomial goes down to up. So also all real numbers. Okay? That's what I should be able to glean from the graph of that polynomial. All right. State the degree of each function. Then describe the end behavior and name the y-intercept for each graph. So we'll start with the degree. Okay? Raised to the third power, raised to the first power, 3 plus 1. That's a fourth degree polynomial. Okay? Describe its end behavior. All right, so a fourth degree polynomial, even power, it's either up, up, or it's down, down. And since the leading coefficient x to the third times x is positive, it's going to be up, up. Again, graph it if you're not sure and to convince yourself. Name the y-intercept. Okay, the y-intercept occurs when you put a 0 in for x. So 0 plus 2 is 2 to the third power is 8. 0 minus 3 is -3. And 8 times -3 is -24. Okay? So we've answered that one. The second one here, you've got to the second power, to the second power ultimately. So that's 4 plus 1. This is degree 5. Okay? So degree 5 either goes down, up, or up, down. The leading coefficient with this negative out in front, you've got a negative times a positive times a positive times a positive. That's going to be a negative leading coefficient, which looks like this, which is up, down. And the y-intercept, let's put in a 0. So 0 plus 2 is 2. Squared is 4. So you have that negative out in front, you got a -4. 0 plus 5 is 5. 0 minus 5 is -5. So -25 times -4 is +100. Okay? So that's all we're doing for those problems. Example 6. The following functions have zeros at -2, -1, and 1. Okay? Match each function to the corresponding graph using its degree and multiplicity. All right, so This one crosses at -2. The multiplicity is 1, so it's just going to cross at -2 without compressing or without bouncing back. That definitely happens, and it happens there as well, so I haven't narrowed it down. This one crosses at -1, but because the multiplicity is 2, it should bounce at -1. Okay, this one crosses at -1. You can see this one bounces at -1. So it looks like this one over here is A. Okay? Let's verify that B is this one. So crosses at -2. Good. At -1, multiplicity 1 crosses there. At +1, multiplicity 3 means it's going to cross, but it's going to compress. Do you see how at +1 it got a little flatter there? This is definitely B. Okay? How about these two? Crosses at -2. Multiplicity 2 means it's going to bounce there. So that bounces at -2. That also bounces at -2. Haven't narrowed it down. This one crosses at -1 with a multiplicity of 2, so it bounces at -1 as well. That one does. That one crosses at -1. So I think that this one is C. And at 1, we're going to cross, but we're going to get compressed there. So do you see how we flatten out just a little bit at 1? Okay. Let's go over to this one. -2, multiplicity 2, so it bounces. At -1, it's a multiplicity 1, so it's going to cross the x-axis. It does that. And then at +1, it should get a little flatter and cross the x-axis there. So that one's definitely B. Okay? Again, you have a graphing calculator in front of you. You could graph these and match them. But this is what we should learn about multiplicity. Okay? All right, so sketch the graph. All right, so a couple things. To the first, to the second, so that's third, to the sixth. This is going to be a 6th-degree polynomial, which means the leading coefficient is positive, the end behavior is up. Okay? We're going to cross at +2, and the multiplicity is 1 there, so it's going to literally cross. It's not going to compress or anything. At 1, we're going to cross, but we're going to bounce off of the axis at that point. So we have to keep in mind that we're going to bounce. And at -1, we're going to cross, but we're going to flatten. Okay, so what I need to do at this point is I need to put that into my calculator, and I need to test just a few points to see where I can get some more values for my graph. So x minus 2, and then I've got x minus 1 squared, and then I've got x plus 1 cubed. Okay? And so I'm going to go to my table, and I want to test the point to the left of this. So I want to go to -2, for instance. And at -2, we're at 36, so we're off the charts. We're going to come from very high, and we're going to come down. Okay, so we'll keep that in mind. Between -1 and 1, say at 0, we're at -2. So we're going to come down to that point. I need to pick a point between 1 and 2. So between 1 and 2 is 1.5. At 1.5, I'm very close to -2 again. Not quite there, but I'm very close. And then if I go out to 3, past there, I'm very high again. Okay? So remember, at -1, we were going to flatten down. Okay? So we were going to come down, get flat a little bit, and then come down to here. Okay? At +1, we were going to bounce. And then at 2, we were just going to cross. So you're going to have a graph something like this. That's not perfect, you know. I mean, if you look at your graph on your calculator, you should get something similar to that. I haven't plotted it on my calculator yet, but it should look similar. I'm not looking for perfection. When you guys do a test, I'm looking for some points. And I've already had some questions. People are like, well, I don't have graph paper for the test. In your resources topic tab on Google Classroom, there is some graph paper. So if you want to print that off, you can use graph paper for your test as well. Okay? Let's look at example 8 here. So determine the end behavior of the graph. So these are just, before we get to example 8, these are some things that we need to do. We went through it on the last graph, but if we want to graph something, determine the end behavior. Does it go up, 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 down, etc. Find the y-intercept, so you have some points to plot. Find the zeros, if any. We could certainly do that to help us get some more points. And then use the y-intercept and the end behavior and all of that stuff to help us graph it. So, graph this function. Well, see, the last function was in that factored form for us, so I had some stuff already simplified for me. This one's not, so let's do some of that work up here. I've got negative 1 x to the 4th, 0 x to the 3rd, 9x to the 2nd, negative 4x, and then negative 12, okay? And so my suggestion for you is to graph this on your calculator. Try to find out where it crosses the x-axis. Now, I found that this crossed at negative 3. So I'm going to go through and do some synthetic division here. Okay, so it clearly crossed at negative 3. It looked to me like it crossed at negative 1. And it definitely did. I got 0 for remainder there. It looked like it crossed at 2. So I'm going to try that one. Okay? And so I was left with x minus 3, x plus 1, and then I had an x minus 2, and then this one is negative x plus 2. Well, think about that for a second. If you set that equal to 0, you get 2 as well. So this is really quantity squared, okay? You can throw a negative out in front to make that negative work for you. Okay, but that's basically what's going on. So I've got some zeros. I've got a 0 at 3. Okay, I've got a 0 at negative 1. And I've got a 0 at 2. Now, at these two places, we're going to cross the x-axis. And at the 2, we're going to bounce off of that. It's a 4th degree polynomial with a negative coefficient, so it's going to go down, down at the end. Okay? So, if I were to put in negative 2, what am I going to get? So let's test some points here. Let's go back into your y equals and clear this. Okay, so negative x to the 4th plus 9x squared minus 4x and minus 12. Okay, I'm going to graph this thing. I'm going to go to my table. And so at negative 2, I'm at 16. Okay, so let's go by 2's here. So, well, it doesn't matter. I'm way up high at negative 2. Fair enough. Okay, somewhere between negative 1 and 2. So at 0, I'm at negative 12. So I'm way down here. And at 1, I'm at negative 8. So I'm here. Okay. In between 2 and 3, so 2.5, I'm at negative 4.18. So 1, 2, 3, 4. I'm like right here. Okay. And then again at four, I'm at negative 140. So let's see what we've got when we graph this thing. So example 8. Okay, so we've got all of our zeros. Oh, silly me. Okay, we've got a 0 at negative 1. We've got one at negative 3 as well. Okay, and at positive 2. So we had that one. Okay, so we've kind of got some points that we're looking at here. What did we evaluate? What did we evaluate negative 2 at? 16. So this one was really high. This was up here somewhere. Okay, and we know we're going down, down. Okay, and so at negative 3 we're going to cross. So we're going from down up to this one, back down, okay? We're coming all the way down to here. We're going to return at that point and then head back down, okay? So I should get a graph that looks something like that when it's all said and done, okay? Again, not perfect, but I've got the zeros, I've got the y-intercept, I've got the multiplicities, all of that kind of stuff, okay? Let's look at one more. Okay, so I'm going to save you guys a little bit of time. If you graph this on your calculator and you go through synthetic division, you find some of these zeros, you're going to find that this factors, okay, to x cubed, x minus 2 quantity squared, and then an x squared plus 3, okay? And again, all I'm doing is synthetic division. I'm putting this in synthetic division. 2 worked twice, 0 worked 3 times, and this one's not very nice. That's imaginary, so I'm not going to actually have places on the graph. So I know we're going to cross at 0. Multiplicity 3 means I'm going to cross there, but I'm going to get skinny, I'm going to get compressed there. I'm going to cross at positive 2, but I'm going to bounce there, right? I'm going to touch that spot and come back, okay? And it's a 7th degree polynomial, leading coefficient positive, so we're going from down to up. So at some point we're going to go like this. We're going to come up through here, back down, and bounce back up, okay? The goal then is to just find a couple of more points. So let's go ahead and put this into our calculator. X to the 7th minus 4x to the 6th plus 7x to the 5th minus 12x to the 4th plus 12x cubed. And then let's see what we've got for points. We know we're going to cross at 0 and 2. We know it's going to flatten at 0 a little bit. We know that we're going to bounce at 2. Now we just need a couple of points. So if I go into my table, -1 gets me -36 already, so I'm way down there. In between the 0 and the 2 at 1, I get a 4. So I've got an idea of how far, and I know what this looks like. So we're going to come up like this. We're going to flatten out just a little bit. We're going to bounce off of the 2, and I know because of end behavior I have to go back up again, okay? So that's kind of what I'm looking at. You can use the calculator to help you through this too, you guys. Look at some points on there, plot some points, but know a little bit about the factoring and then the end behavior as we go, okay? And I think I'm going to stop there, all right? So take a look at Google Classroom, make sure that you do the example. Ask me anytime for questions, email, comment on Google Classroom, and we'll figure it out. Thanks.